Hey guys, I was thinking about what to work on after implementing the really naive entity component system, and one of the ideas that I had is a view, an entity view. So if we look at the way the entity component system is organized right now, so here when I loop through the entities, what we basically say is if the entity ID is player, then we go and fetch the player position and the player facing direction here, and then we fetch the player cooldown. And then later on in rendering, we also fetch the player texture. And then for the ghost, we do the same exact thing. So basically, we're looking into these components very frequently. Here, you can see a lot of components cooldown, components facing. If we can create a view over a specific entity, then we can get at these properties a lot more easily. Call it an entity view. And basically, we're just going to have pointers to everything in these positions here. We also do need the entity ID. We're going to take pointers to has. We need to bring in not just the value type here, but we also need to bring in the flag about whether or not these particular properties apply to a specific entity. So this would be a has of math vector 2f. And then basically we just grab all these guys here. And then we'll have a utility function that will be, or utility procedure that will be like make entity view or get entity view or something like that. Or maybe we should have a pointer to entity, but no, we'll just copy it in directly. We don't ever intend to modify the ID of a singular entity through a view. At least I don't intend to. Essentially, we want to be able to modify the entity through the view. And because these are arrays here, the implementation of the array type has a pointer to data. So I don't think we need to take a pointer here. So position is going to be components, positions, entity index, and we'll take a pointer to that. So now let's try to actually replace some of this code with entity views here. So for entities right here, what we say is ev is make entity view, and we take in the entity index, the list of entities, and the components. So we'll have ev position prop, ev facing prop here. So I'll finish the replacements here, then we'll compile and run and see what happens. The entity view for the player appears to be working. Now we'll swap the implementation for the entities. Okay, well the view seems to be working. Render simple entity. We don't need to take in the components or the entity index. We just need to take in the entity view. Make entity view, the index, entities, and components. Looks good. Okay, so there's an entity view. There's another interesting thing in Jai called for expansions. This for expansion here will take as its first argument some struct, basically something that has a collection of things you can iterate over, and then body here as type code. Body, right, goes here, pound insert body, so you get code replaced. You just paste the caller's code into here. And so we could define our own for a collection of our entities and our components. It index would just be the iteration index, and it would be an entity view. If we did something like this, then down here in for entities, I would actually have to wrap this in something. For example, this is just be EC. For example, EC would be a struct containing entities, which would be a list of entity and then components. And I could implement a for expansion for EC. I would do something like EC entities components like this, and then we would not have to call make entity view. It would automatically be available for us. But as you can tell, this small amount of code that I wrote here relative to what I have currently with just make entity view, if I get rid of this, it's actually not that much code savings. There's not too much sophistication there. The make entity view is doing the tedium for us. So I don't think we really need to bother with the for expansions here. So let's get rid of the entity, get rid of player and enemy. So destroy takes an entity. Oh yeah, we did not implement destroy for the ECS. I mean, it could take an entity view, and we would say SDL3 destroy texture, entity view, tile set, prop dot atlas. One thing we could experiment with actually is simulating destroying an entity. When we access different properties through the components of an entity, we do that by entity index in the list of entities itself. So the entity's position in a list of entities also determines the position of the entity's properties in components arrays. So this means if we want to delete or shuffle the list of entities, we also have to shuffle the list of components as well. What I'm going to do here is add another convenience procedure like delete entity. There's this call here that we will be using on the arrays. This is array unordered remove by index. I'll show an example of what a deletion on a fixed size array looks like for those who haven't seen it before. You get the element at the last index, which is just the count of entries in an array, and you subtract 1. And if the last index is not the index that we want to delete, then you just overwrite the entry at the index we want to delete something at with the element at the last index in the array. This is why the unordered word here is very important. Now we do have ordering in our entities, right? We don't ever want to be swapping something into position 0, because that's the player position. When it comes time to move them in the map, we just loop through the list of entities from beginning to end, and whoever comes first in the list of entities gets to move first, that's the player, and then who comes after gets to move after. So one of the entities is more privileged than another of the entities. When we actually introduce speed properties, then we can start doing sorting and filtering on these arrays. But for now, although we do have order, we're just going to say it's an unordered array in our case. Now I can easily imagine a bug waiting for me where I add a new component array to the collection of components, and I forget to update one of these convenience features. So let's see how long I go before that bites me. Okay, so this will be delete entity. Now the question is, how do we test this? Should we actually guard against less than or equal to 1? Because I don't think we ever want to delete the player. Delete non-player entity. I can just test for a special button on the input side, and if that button's pressed, I can just delete an entity. How about D? D will be for deleting entities. I think it's called SDLKD for the D key. We can test this real quick by both building and also just printing down here in update. If input.d, then print D was pressed. Okay, and I pressed D, D was pressed. So I might need to debounce that. Seems to go for 2+ frames. That's going to delete a lot of enemies. We will say entity delete non-player entity. The entity index is going to be game state entities count -1. So delete non-player entity, we'll take the entity index and then game state entities and game state components. That should build. Oh yeah, we need to pass the arrays by pointers. Type wanted is a view over has t is vector 2f, but the type given is the actual array itself. So I guess I need to take a view over it. I need to create a view over it. When we call array unordered remove by index here, as I mentioned, that's going to try and reduce the count. However, it's nonsensical to reduce the count of a fixed size array. It works with entities because entities is a view over backing storage, but we don't ever deal with any views over the components because we allow the entity's view itself to be a view over the backing components. We'll just copy this logic into our own thing, I guess, but we don't ever want to decrement the count. We'll create a function or a procedure called sudo delete, and that will just copy the element at the last index, an index where we want to delete something. We just sudo delete all this stuff. We have a generic argument of an array, and then we have an index that we want to do a pseudo delete at. We just get the last index, which is the count -1 of the array passed in. And if index is not equal to the last index, then we overwrite whatever is at index with whatever is at the last index. So we'll call pseudo delete on these guys. So now we need to look back into debouncing. I don't actually want to do that. That just seems like annoying work. So what we will do here is just create a global really quickly. Deleted is false. If input D and not deleted, then we'll only delete one entity. Deleted is true. If we say GS entities count -2, this allows us to exercise the full logic in pseudo delete because we don't want last index to be the index that we want to delete at. So we'll delete the middle ghost, and then we expect the third ghost's data to be copied over the middle ghost's data. And essentially, when we reduce the count of the GS entity's view over the entity's backing storage, then when we do update positions and we do entity render, we expect to only see 2 ghosts on the screen. So let's get in a position where there's 3 ghosts. I'm going to press D, and it died. Okay, we can run this in the debugger, presumably reproduce this immediately. Yeah, reproduce it immediately. So there's GS components. I don't know if I can pretty print that. P pretty -- GS components. Oh, that's cool. Check that out. 0, 0. That's going to be a problem, and that's at position 2 as well. I guess I would expect this data to be here. Has is false. This is the problem, right? So because it's a fixed size array, array.count is going to be 100. -1 is 99. So it's doing what it's supposed to do. It's taking the very last element of the collection, but it's not doing what we want it to do logically. And I get tripped up here because we're dealing with entities as a view, which always has a count corresponding to the total number of enemies. So that's correct. However, components just holds a bunch of fixed size arrays. They're not views. So for pseudo delete here, we need to pass in index and last index. Last index is going to be entity index, and then it's going to be entities.count -1. We'll rebuild. So let's move into position, and I'll press D. Well, actually, so it's not working. I already have another logic bug here, but we're calling array unordered remove by index, which is decrementing the size of entities here. We actually want to capture entities count -1 up here. That did fix the problem. Boom. So you saw that I just pressed D and that ghost is gone. Oh, he's back. He's back. He's back. Right. So if I press D, here's the issue. We track the total number of entities that are alive through a view. Now, because we take this view by value and not by pointer, we do update this view correctly. We don't propagate the new size back to the caller. However, that doesn't explain why all of a sudden a ghost shows up when we call update positions. Because we don't update the count in the view on the caller side, ghost in position 2 and ghost in position 4 until we move again are just standing on top of each other. Let's try and take this by pointer here, and this should propagate mutations back to the caller. I'm going to move, press D, boom, he's gone, and he should stay gone. Yeah, now he's gone. Okay, we'll get rid of the D stuff here because we've tested that as far as we can with this simple code here. This is how we set up ghosts and players and stuff, right? So we could probably have a support routine here to set this guy up. Let's deal with views, right? We don't want to be explicitly accessing the components and stuff. That's the whole reason why we implemented a view in the beginning here. So we'll deal with views. Okay, we take in a pointer to an entity view. We set the ID, position, facing, cooldown, and tile set. So we will now say entity.make entity view. We need to dereference, right? Player seems to be okay. Then we'll do the same thing for enemy. The program crashed because of an integer division by 0 error. Now that should fix that. There we go. Oh, now am I the ghost? Everything is fine as is. If I press right, all of a sudden I become the ghost, which is actually pretty sick. And then like the graphics start freaking out too. Like, whoa, whoa. All right. I'm having too much fun here. We gotta go fix this. So we've narrowed down that part of the code. It's not about the movement. It's not about my update either. It's all about whatever's going on right here. Is the ID being set to player for everybody? Set to 0? Oh, wait, was I doing this the whole time? Was I calling initialize player the whole time? So build it, run it. Okay, no, it was not that simple. Why would I be a ghost though? I'd be a ghost if the tile set. Well, look, also the players, like everyone's mimicking my behavior. Okay, so IDs are all player for everybody, right? That's the problem. There we go. This should be also, 5 should also be player, right? Because player is 0 ID. It's getting, so this is either getting default initialized or it's not getting reflected back to the caller or something like that, which might also mean that we just lucked out with the first entity, initialize player right here. And that's after we get an entity view. And we pass in the entity view. The entity view is on our stack. Wait, I think that's the problem. I remember early on in the stream, I was like, we're never going to be changing the entity type when we deal with entity views. So obviously I was wrong about that. This even needs to be a player right here. Oh, excuse me, a pointer. Can I say using and then take a pointer and just have like its members be available? That would be super sick. It can. That's cool. So now everybody gets updated correctly. So everyone was becoming a player because I was returning some stuff on the stack, modifying that, and it wasn't getting propagated back to the backing data structures in the game state because I botched the pointer logic. For anybody watching, thank you so much for tagging along for the adventure today, and I'll catch you in the next stream. Peace.